Well, actually, what you need to do generally is, yeah, okay. So the first thing you are going to do here is to first draw your reinforcement lines, which are the rebars, and then I don't know if you would understand. So these white, those ones, the lines in white are the reinforcement. Then this dot is like a form of indicator that that is calling out the rebar, which is this. Then the green lines showing you the arrow of what extent is going to reach on the spans throughout the spans. I mean, so you see, this arrow goes from this to this, meaning that this call out point is actually saying that this buyer. Oh, actually, I should change this already because I believe, or I later found out that this slab here is not continuous. So this should be returning back. So that's a mistake from my end. So basically what this means is that this bar here is extending or being arranged, is going to be arranged from this place, just by from this place to the end of the arrow here. So similarly, yeah, this particular one, this is our distribution bar, which is the secondary bar, is going to extend from this point to this point. And wait, I'm looking for the main bar. Okay, the call out here says, you see, R16 at 300 mm, which is bottom top, which means is our secondary bar, obviously. So I'm still looking for the bottom, okay, which is this is the bottom. So what I actually did was that, knowing that this bottom bar is long enough, like it's going to be the same, is yes, it's going to be the same destin, actually the same arrangement here also. So I just generally, like, I just used it generally for the two panels. Like this panel is similar to this panel in terms of reinforcement detail for the main bars, which is R16 at 200 mm, 250 mm, I mean, so which is bottom. So that is why I extended it from here to this place. And then have in mind that your bars must not extend more than 12 meters or 12.5, because I believe 12.5 is the highest distance length you can get for transportation purpose, because taking bars up and down. So that's that. I believe you understand that at least. So what I did, basically, I cut it here, so it shouldn't exceed 12 meters. I cut it here and now then extend, or like use another bar for this part. You see, which is this. Where is the call out? Okay, which is this. Oh yes, it's also R16 at 200 250 mm, but as I said, I don't want to use it. I don't want to extend it to this length, because obviously, of course, it would exceed that 12 meters. So that's that. And then, as I said earlier, this is the distribution bar, and it's returning like this. So for this, yes. So this distribution bar also is going from this place to this place. Actually, I could have made it. Yes, it is actually. So it all like it's it's being extended from here to this place. In terms of distribution, it is distributed literally because they all have similar or typical arrangement, which is that. So from here, can you see as I joined the arrows? So this basically mean it doesn't end there, that it still extends and continues, yes, up to the end there. And I shouldn't have even labeled this, but I called it out as bottom top, as per required. So that's that. And then the the reinforcement at supports, which is this particular one here. It's is the top reinforcement, and it's going to be arranged from this point to this place. And here is the call out with my green line here, and the white line being the reinforcement bar itself. So this is also a support bar, top. Then our distribution bar for the top. Yes, this, where is it? Oh yes, this is it. Let's try. Okay, yes, this is it, and it's going to actually um you know be extended from here to here, then the other span, like the other side, just for it to contain the bar. Yeah. I should have shifted this a little bit to the back. So that's that. So this, then the call out here, it says, yes, it says top bottom. Yes, R16 at 300 mm top bottom, which is that. So I believe as I explained that suffice. Then the section. So our section 1 here, cutting through this side. So our grid lines are going to be 1 A B C D. Oh, A B C, yes, A B C. So this is it, cutting through A B C. So which is this, as I said earlier. So this, yes, this is a continuous beam, and I just I cut it here. So our bottom bar is the main bar, which is R16 at 250 mm at the first span, AB span. Then the BC span also the same thing, similarly R16 at 250. Then our distribution bar, it's 16 at 300 mm. Then the top, oh okay, so this one just goes from here and return like this to cater for shear, because basically slabs generally, like this type of slab, is designed to be simply supported at this edge here. So you don't really take theoretically we don't need rebar to be up here, but to cater for the shear, so that you just have to provide it hand for torsion also. So torsional moment occurs at the corners and supports, basically mostly corners, but without providing it at support, you don't have any bars in the corners, so you have to provide this. And usually is it's usually 0.1 of the length of the total length here. Then from the center of course, if you measure from here to here, it should give you 700 mm, because our length, like the length of our so the span of our slab is 7 meters, so here should be 700 mm. Though you can actually make it exceed 700 mm, but that's 0. So what we have at support here? At support here, we have our main reinforcement at the top, which is R16 at 200, and the distribution top bar is top bottom, which is this at 300, 16 at 300 mm. So similarly here to the same thing. So that's it. That's for section AA. Section 11. So that's section 11. Then for section 22, just basically what you have there. Call through your section 22, and you have that. We are going to get to the bar bending schedule later. So our beams. This my beam reinforcement, or my beam detailing, might be slightly different from what you guys will do, because what I did was that, seeing the nature of my whole structure, I see that I would kind of like require a beam of greater depth. So I don't want to make it great, no, because of my span. This is spanning 7 meters and this is spanning 8.4 meters. So I don't want it to be so big and have a lot of reinforcements just forced inside it. So what I did was that I clamped it at the supports. I didn't make it simply supported. So it is fixed here and fixed here. So obviously they would have moments. Did I put? Oh, that's the problem. I actually haven't. Sorry. I didn't fix this particular beam. 5 6. I didn't fix this one, but I fixed the other one. This was the first one I designed, so I didn't fix it. Did I? Yes, I didn't fix it. So that's why it's giving us, like, that's why it's requiring bigger or larger this thing, breadth and depth, which is 700 is so much. So that's 700 depth, like the total depth of the beam is 700 which I really don't like, and it's not also practical. Well, it's theoretical. So then this, okay, let's start from this one. So this is my beam 2. I don't know if I actually labeled it there. Oh, I think I have a layout, a general layout. Yes, yeah. So yeah, so this is it. This is my beam 2. So I fixed, this is my beam 2 here. So I fixed this side and fixed this side. Do it continuous, but I fixed it, yes. So it's going to be fixed in reality. So this is the only one I didn't, fix, because it was the first one I designed. I was like, let me just pin it and see, and I pinned it, and it's can you see the depth and breadth being, bigger than the other ones? So the rest of the beams, basically, I fixed them at the edges. So yeah, fixing beams make them require less depth and steel, because it's going to distribute the moment at the top and bottom. Everything would kind of be balanced. So that's that. Let's go back to our beam detailing. So let's start from here. So since I fixed it, so it is obviously, yeah, I fixed this one, but it's obviously continuous, as I said earlier. So that's continuous. So being fixed again. So it requires eight numbers of 25 bar at the support, which is what I should extend this to this place. I will do that later. So I should extend this to this place. So that is how it's meant to be. So that's fixed at the support. Then the top span really doesn't need reinforced, because there's no moment here. There's no negative moment here. We only have positive moment at the span, at the main spans of clamped beam. So that's why when we calculated this beam here to be three to require 3R25, but then why not 4? So that's why I used 4. Why not try 4? So I used 4. So this and this should be extended to this place. Oh yes, I still need some work here. Oh well. So this bar here should be extended there to meet the requirement, which is, yes, I did mention, which is from the center, like from the center of your support to a distance of 0.3 of the length, which is, our length is 6.16 meters. Yes, at least it should be at least 0.3. Let me see. So 0.3 of this length of the span. That's the extent at which the support should extend, or the bar should extend. So similarly, so here we have a lower or a lesser span length, which is 5.6. Here we have 6.16. So that's what makes this longer than this. So that's also that. Then this also should be extended to this place. I will correct all this later. So this should be extended to here. So that is it. So similarly, just as I explained that, I haven't finished with the call out here. So I'm going to call this out. I don't even know what amount of reinforcement is there. So these are the sections. I'm not done with the section yet. I'm not through with this particular beam. So back to beam 5 and 6, which are typical or similar. Let's go back to here. Yes. So where's our 5? So 5, so yeah, this beam and this beam are basically the same, like they carry the same load and behave the same way, so we are designing them as one. So this here, this and this is one beam, but two is a unique, like is a kind of standing alone beam. You don't have any similar beam to this, while this, so beam 1 and beam 3 are also similar, are likewise similar. So beam 4 and beam 7 are also the same. So you are going to design them like alike. So yeah, remember I told you that this particular beam is simply supported, so that is why we don't really require much area of steel. Provide calculating the top reinforcement here, just the, the minimal or nominal steel area that is required on the top span. Yes, on the top span of the beam, because there's basically no moment, and you don't need reinforcement there at all. Just provide the minimal. So at the bottom where you have maximum moment at the span, so we are providing 8 R25 at the span, and then just by the supports providing the just a minimum or a minimal steel area, which is 4R25. So at this support bottom, similarly, just as the top, this should be, I should have just continued this as four numbers of R25. I would update this later, because it shouldn't be easy to construct, providing I haven't provided 4R25 here, and then just changing all of a sudden to R16. That's not so. And so now this is where we now have issues, because this is where like this is the most critical part of the beam at our support here. So yeah, this carries a lot of moments. So I've actually done the writing here. I extended those bars to where they are meant to be extended to, which is, as I said, 0.6, no, sorry, 0.3 of the span of our beam, which is 7 here. At least it should be that, or yes, or some use 0.25. So you can use 0.25 or 0.3, but going for 0.3 according to the textbook the man gave us. So that's, so similarly here to 0.25 or 0.3, the span is what you're extending this top bar, so which is this. So now we have 3 layers of reinforcement here, because we can't stack, we can't just pack 25 diameter steel into one layer. So that's why you just have to divide them and arrange them in a way that it would conform to our code, which says, yeah, this should be it. Yes, this as, oh, I have not updated this, so I would update it, the sections. So yeah, when you cut a section here, it should be giving you 625 diameter at the top on 3 layers. So 666. That was what you are meant to see. So that's that. So explaining that alone should suffice. So here is beam 4 and 7, as I said, are similar, and beam 3 and beam 1 and 3, which are also similar. Typical beams. So only beam 2 is standing alone unique. So that's it. Hope you enjoyed. Please subscribe.